everyone. Welcome back to Courtside View, another episode brought to you by Courtside Digital Insights. I'm your host, Iman, Senior Global Product Marketing Manager, and today we are diving into a topic that sits right at the intersection of data, tech, and innovations in pharma R&D. In today's episode, we are exploring how knowledge is connected, traced, and leveraged to accelerate scientific discovery, and what that really means for the future of drug development. Joining me today, two brilliant minds shaping this space, Venkatesh Makatali. He is Director of Product Management for Knowledge Business at Kaizen Digital Insights, who leads development of solutions that turn biological data into actionable insights. And Dr. Alex Jarash. Alex is a global head of pharma and life science at Neo4j, a pioneer in graph technology and knowledge modeling. Hi, Alex. Hi, Venki.
Hey.
Hey, nice to see you.
So welcome to Courtside View, Alex. And Venki, this is not your first time. Still welcome.
Thanks
you
for
having me.
Go to this. Let's do this.
So we will break today's episode into a few segments. The R&D challenge, making the data work for you, traceability, trust, and transparency, and data exploration insight. So let's start with the reality of modern pharma research and development. It's innovative by nature, which means we are often looking for things we cannot describe yet. And often you are swimming in highly connected, heterogeneous data. And yet, the first 80% of data scientists' time is often spent just running it to make it usable. So let's go to the fundamental, something which is very fundamental is traceability. When you identify a relationship, whether it's between data points, entities, and concept, how do you go about tracing the origins and evolutions? And over the time, how has our ability to do that has improved? Venki, do you want to chime in?
Yeah, surely. So to preface this answer or to comment on this, we have two different products. One is what we call as biomedical KBHD, which is manually curated data or knowledge graph. And then we also offer something called as biomedical KB AI, which is entirely generated from NLP and large language models, which extract information from structured and unstructured data sources. And across both of these products, obviously for our clients and for our partners, having confidence and being able to easily verify sources and experiments, supporting the findings and the content within these two products is essential. And so from our side, what we do is that we make this data available as something that isn't a black box, right? You can actually look through every interaction, look through source citations, experiment types, and methods. And so you get completely comprehensive provenance where you can trace back the data lineage back to original empirical studies from the literature, which then have given rise to some of the conclusions that we've included in the knowledge graph. That's one. The second piece is also just accessing all of these findings easily. And so there are various hierarchies that we've included where you can not only trace something at, say, a variant level, but you can also go to the gene level, to the cellular level, the subcellular level. And so there are various dimensions to this data. So you not only take a look at, okay, is the finding related to a variant? And is that variant in a particular sample, observed in a particular cell type? You can also find various levels of it through both gene hierarchies as well as organismal hierarchy, but also then looking through disease hierarchies. We know that, of course, biology is complex. So you get all of those traceabilities to then be able to say, okay, I have absolute provenance on where I found a particular finding, what was the source, and what is the context to it. So that's sort of what the PKB brings in, right? And typically, a lot of this work, it gets done over decades, right? And so since we've done it, our partners can now just go straight into the insight generation.
That's awesome. And before Alex chimes in, I want to say to the audience that you often hear us talk about BKB. Essentially, we're talking about biomedical knowledge base, which is Kaizen's knowledge base. Alex, do you want to chime in?
Yes, just add one comment here to Venki's explanation. So on the one side, we have BKB, right? The HD version, the AI version. Maybe customers even come with their own additional data sources or the latest updates from yesterday or the day before, right? But also they are integrating and connecting that, and that's why Neo4j as a graph database underneath is super important. They have their own data coming from experiments, right? Omics experiments, what have you. And so you can use that from left to right or the other way around. You can say, well, I have my hypothesis coming from my knowledge graph, right? And we have all these findings and the curated data. Do we have actually internal data, or do we have experimental data in animal models, in humans, right? In order to prove or disprove my hypothesis, right? Or the other way around, what we see with the data scientists, they see a signal or a significance factor in the data coming from their omic experiments, and they want to have a look. Hey, there's this gene, and what do we know about this in that gene, right? Or what do we know about this RNA or this variant, right? And this is where the connection between the experimental data as well as the world's knowledge, right, is directly connected in one unified database.
That's awesome. And once you have established structure and traceability within the data through ontologies and metadata and graph relationships, as you mentioned, how does that translate into practical impact for an R&D scientist? Can you talk about a little bit on that?
Venki, you want to go first, or?
No, go ahead, and I'll add in.
So what we see is that customers take the data, load that into Neo4j, and then directly explore that, right? At the same time, we talked about traceability of all the nodes and relationships to all the facts, right? But there are different layers. Venki talked about ontologies, right? BKB comes with an ontology. Kaizen has the own ontology, right, which is very fine granular. There might be another ontology from the academic sector. There might be an internal taxonomy or terminology, right? We can easily integrate that as a second or a third layer into the graph database. Like an ontology is usually a tree-like structure. A tree is a graph. At the same time, we have that with metadata. So where does the data come from? I don't know, some metadata on microscopic images or what have you, right? All this metadata is just another layer in the data. And this is where the data scientists use the different layers to even interconnect the data, but also explore the data and find the insights, right? And in the end, the overall goal is to speed up the process of drug discovery or speed up the process in competitive intelligence.
Yeah, I think one of the interesting things that I've seen play out is it's not just the data scientists, right? It's also bioinformaticians, it's also biologists who can use this content. There are a lot of different use cases that play out, right? One is where you're visually exploring the content, and it's often said, right, in pharma drug discovery, the serendipity plays quite a big role when the person with the right knowledge, with the right background comes and looks at certain data presented in an ideal way, and he makes certain conclusions, right? Discoveries, and that's what we typically call as serendipity. But that can't happen if the data isn't quite presented in a way where our brains can digest that information, can already start making links. And I think that's one extremely powerful thing that comes out through the Neo4j platform, right? Where you look at the Neo4j browser, which presents your content in a very visually stimulating fashion. And when you add in curated data sources like ours in it, you will not only see these nodes, you also see the relationships, you see the edges, you see information on the edges on where it's coming from, what's happening. And so I think that is extremely powerful to power some of these discoveries. And that could be done by basically anyone with access to a computer and basic knowledge of looking around, right? And then on the complete flip side of this is advanced methods now that have come out, right? Which is Gen AI, think about dashboards, chatbots, and now you're really taking it to the next level, right? Now you're no longer relying on pure serendipity, which is by chance, but now you're very purposefully taking actions. You're purposefully running different methods. There's graph data science libraries and so on and so forth, which will then make use of all of this ontology that I've described before, all of the contextual information, and then now you can start really doing something much more advanced. And so that then enables you to run advanced applications, right? Whether it is um, building together contextual chatbots and other applications, and it's just endless, right? And we can discover more during this conversation, but I think it just really enables the scientist with an extremely powerful tool that they can go with.
Definitely, Venki, and you made a very good point. There are lots of different users, right? We have clinicians, we have bioinformaticians, we have biochemists, right? So we have techie users, right, that can run Cypher queries, that have Python notebooks, right? But we also have those ones that do not speak Python or Java or any programming language, right? And we kind of democratize this data by giving them a tool set like GenAI to query the data, right? We can think about semantic search in this knowledge graph. We can think about what Venki said, graph data science, to combine the both of them, right? To use the actual information coming from the relationships, coming from the connections of the data in order to incorporate it in our analysis. And Venki, you gave a little sneak peek to what we can do on top of the data and on top of the database layer, right? This is where the fun starts, right? When we have the data ready, and when we can bring that to the users, we have a variety of different use cases. We have a variety of different applications that we can ship to the users, to the customers, in form of a dashboard, in form of a tool that lets you explore from any node to any other node in the data set, to a programmatic API, to whatever we have as semantic search. Even maybe in the future a conversational tool.
I love it. I essentially want to repeat what Venki mentioned and Alex, you mentioned as well. Whether you are a techie, you know how to code, you know how to build a model, or you are a researcher who cares for the end goal, this is all for you. And the graph adapts you, not the other way around. So let's get a little bit nerdy at this moment and dig into why behind the technology. Why graphs? What is it about the graph databases like Neo4j that makes uniquely suited for kind of complex interconnected data challenges we see in pharma and biotech R&D? And why wouldn't something more traditional like a relational SQL databases be able to handle that just as well? Can you talk about that, Alex, maybe?
Absolutely, and I might have a very biased opinion on that, but
Go for it.
this is based on my previous career in the pharma industry. I was in the world of a pharma industry that deals with a lot of data, right? Obviously, all the data that is coming up and that will come in the future is not fitting in a rigid structure like a table, right? The data is changing over time. We have different data formats coming from the scientific freedom, right? There are some scientists that are doing it like this way. There are others who are doing like that way. There's no wrong and right, right? It's rather like somebody is doing it a little bit different, and this flexibility comes with a price, right? So the flexibility can end up in chaos, right? So that's why we try to structure the data and also curate the data in terms of BKB, but we still want to have this flexibility. At the same time, and this is what I saw in my career as well, the data by definition is highly connected, right? A gene is coding a protein has a function, the function is a term of an ontology, right? These are all these nodes and relationships that you can see in a scientific publication, that you would draw on a whiteboard if you are a user. And this is exactly what a graph is. And yeah, that's why I think a graph database for these sorts of this scientific freedom in pharma R&D or biotech R&D is very much present, and we need a technology underneath that supports that. And I don't want to say here, maybe to have that as a comment as well, there are a lot of use cases and there are a lot of needs for SQL databases or for structured data, right? But in our case, with the highly heterogeneous, at the same time, highly connected data, this is where a graph database is well better suited.
Yeah, and I think the evidence points to it, right? If you look at most organizations today, most of the top 10 pharma, even you can go further into the top 20 pharma, most of these organizations have realized, right, that the data that we are generating today is extremely interconnected, is going to scale fast, and it's going to explode within few months, forget years. And they've realized this. They've also realized that it's not just about representing data. It's also about, okay, how does this then enable applications that need to be served to to their employees, to their scientists, to then take them a step further. And you've seen this happen now. Like all of them have, maybe not all, but at least most of them have moved towards graph representation of the data, right? And you see this across the board. And that has really almost opened up this sort of floodgates, if you will, right? Once you have this data represented in this fashion that enables people to do downstream applications, it just opens up a new avenue, right? You see so many things happening, right? Advanced agentic framework that is just so well tuned to this graph representation. You have various applications that are built on top. There are so many organizations that are coming up with centralized resources and tool sets that are built on top of databases. So I think the list goes on and on, right? And I think the sooner you, as an organization, understand, and it may not be for everyone, right? But I think it seems like it works for most organizations who are going to commit to a path to moving towards using GenAI, using large language models, using these next gen architectures, and have this, all these points that we've spoken about, traceability. Graph representation has enabled all of those applications really well. And so that's why, I think that for our data as well, it's just a natural fit.
Sounds awesome. I picked up something what Alex mentioned. that's the sentence for the day. Flexibility can end up in chaos. And the way he supported that's really nice. And so let's zoom out for a moment right now. And we have been talking about exploration, navigating relationships, tracing connections, surfacing hidden insights. But what about taking the next steps? How do we move from exploration to prediction? In other words, once you have mapped the landscape, how are teams using this graph-powered insights to anticipate outcomes, model hypotheses, and even guide experimental design?
I'll take a shot. I think Alex can probably contribute very richly, but I'll preface this by saying, look, we speak with a lot of our partners and customers where they want to set up a data foundation that then enables them to do predictive analytics, to build machine learning methods, to do things like link prediction. And a lot of that is potentially built on things like, graph embeddings. And the main piece here is, in order to do all of that, you need to be able to trust the content, right? Can you trust the data upon which you're building all of these predictions, right? If you can't trust that data, how are you able to trust what the model is going to predict, right? And that's where I think that we feel we've done enough over the last 20 years to gain that credibility. Our data has been cited more than 50,000 times by researchers across the board who vouch for this content, right? Whether it's consumed in the form of the engineering pathway analysis solution that we've offered over the last 20 years, or it's now in the last few years through the knowledge base that powers the engineering pathway analysis. So it garbage in, garbage out, right? I'm going to use this cliche term, but it couldn't be more true now than ever, right? You need a solid foundation of data before you then land yourself into building these analytics and predictions. So that's sort of the quick sort of ad. But let me pass to Alex. I think he has a lot of insights here where, how Neo4j really enables scientists to do this.
Yes, and I wanted to take one step back and refer to our earlier conversations, right? We have the data in BK, we have the data of BKB or what have you from the customer, the data in the database, right? And we talked about this exploration and so on and so forth, right? Actually, this has its limitations, like from our humans' minds, because we can handle several hundreds or maybe 1,000 nodes, right? Reality looks like that we have tens and hundreds of millions of nodes and relationships in the database. So this is how big BKB and also, right, the customer's data is, right? So can we handle that with our calculators and the pen and the paper? No, we can't, right? So that's why we're leveraging algorithms and machine learning techniques in order to find patterns, unusual patterns, clusters, right? We want to predict new relationships. Venki talked about link prediction, right? But this is what we want to do at scale, at tens of millions or 100 millions of relationships and nodes. This is where the machine learning part kicks in and the graph analytics. So this is what we can do at scale. At the same time, Venki talked about embedding. So we want to provide insights to our maybe existing machine learning workflows or pipelines that a customer already built, right? But they only speak vectors, right? We can easily transform the information from what we have in the database in form of a vector and serialize that out to our machine learning pipelines. But we can also cover the whole context of the actual data point in order to incorporate that into our machine learning techniques. And this is a very, very powerful combination. So we have the data like it is, right? Intuitive as nodes and relationships. We can leverage the additional information coming from the relationships. We can do that at scale. And we can connect that with the machine learning pipelines in order to find new things or uncommon things.
Sounds great. Venki, do you have anything to add over here?
No, I don't think so. I think the only thing I would add is that there is, if you look at just the kinds of applications our customers have done, it really ranges the gamut, right? And as an audience who may be listening to this video, if you are a data scientist, if you are a decision maker, the sort of question you want to ask yourself is, how do you, if you're a decision maker, how do you enable your team to go further, right? How do you enable your teams to build the right models that save time, but also then from a quality perspective is reliable? And so that's where you can start with the foundation of BKB and Neo4j together, and that really saves you time, right? Then you can go focus on the next sort of a step, and towards that, I think as a combination of these two products, you get a myriad possibilities in where you want to start. Whether you want to start with graph embeddings, do you want to build out graph RAG models, do you want to build out a model context protocol? There's so many architectures that have come through, but all of them are going to start with a knowledge graph, high confidence knowledge graph. It's going to start with a set of technologies that enable you to build these on top of that, right? Is there a CSV file? Is there a set of embeddings? Is there a knowledge graph? Is there a representation, a structure? So all of those questions that you need to be able to answer before you start your predictive analytics, that's where we, as two organizations, have come together and made this more easy to get started with.
Yeah. And maybe to add one point to Venki's comment here, the decision makers, right? How do we actually start? Well, it's rather minutes. And maybe if you combine that with some internal data, maybe hours, right? It's not that we talk about two things coming together and we need half a year, 1 year to set this thing up in order to create value, right? No, this is rather like setting up the database, ingest the data in 5 to 10 minutes, and boom, you are good to go, right? So we're talking about minutes and narrow down the time to go to market. So we can speed up things immediately.
That's such a good point, though, right? Which is oftentimes you go to conferences, you listen to talks where people are talking about all of these predictive analytics they've done. They've come up with. There's always this sort of abuse term, right? I've used AI to come up with 15 targets or whatever, right? And there are teams of scientists who've done this, teams of AI researchers who've done this. Well, this is now democratized. It's no longer done only by the few organizations who are in the news, right? Anyone with a laptop and who's willing to spend a couple hours can do this now. And that's what we are showing here, right? With the data as a starting point, with these technologies from Neo4j, you can start today within a matter of minutes, right? Yep. It's not esoteric. It's not that esoteric. All you need to know is be open to learning a few things and be able to get your hands dirty, and you can get started. And I think that's what is going to, in my opinion, hopefully change how we do things.
Yeah. This has been such an insightful and engaging conversation, Venki and Alex. Thank you both for your perspective. Before we wrap up today's episode, I love to give you each a moment for any closing thoughts. I pretty much think that, Venki, what you mentioned, that's going to be the closing thoughts. But if there are any particular key takeaway or a future trend that you're excited about, or call to actions for our audience, what would you like to leave us with? Alex, we can start with you and go to Venki.
Yeah, for me, the take home message as an audience would be like when I was a user and when I worked in the pharma industry before. This is not some theoretical stuff that we are talking about in a publication. This is right, like hands-on, as we just mentioned it a minute ago. It's like, get your hands dirty, 10 minutes data loading, and you're good to go, right? And maybe to add one more point on that, right? I'm thinking of several use cases, several different departments that are querying the same graph, right? So we talked about genes and proteins in the beginning, but there are also clinical trials, right? So there are 2 or might be even 3 departments that are querying actually the same database, right? So you even accelerate by reusing the same knowledge graph, and it can grow as an enterprise knowledge graph. So for me, the takeaway is start doing, get your hands dirty, and don't think that this is a theoretical thing or like a something that is floating somewhere in space.
Yeah, and all I'll add as closing parting thoughts here is, we are all in this together, right? Like as a community, and let's work together. I think I've said enough now, and I won't belabor any further points, but let's work together. Neo4j provides a lot of tools where you can start quickly. We are open to collaborations. Let's work together. Let's find out new use cases, and I'm really really optimistic about where things can go, right? I think as long as you're you're willing to learn, and you're willing to start from what people have built, I think it really helps us take it further, right? Like, let's stop reinventing the wheel, right? People have done a body of work. Let's build on top of that, and let's collaborate. And I think that's sort of my parting thoughts, that both as organizations, we've also found each other because we were willing to look outside and think together. And so I just welcome the community to come reach out to us and look at how we can enable additional applications together.
Well said. Thank you both. And that's it for today's episode of Courtside View. To our audiences, if you're working in the pharma research and development, in drug discovery, if you're buried in data, think about what a graph can do for you, especially one built on trusted scientific foundations like biomedical knowledge base. So until next time, we are from Courtside View. Stay bold, stay curious, and subscribe us over here. See you next episode. Bye, Alex. Bye, Venki.
Bye.
Thank you.
Thanks for having me. Bye-bye.
QIAGEN.
Sample to insight.